It's been 5 years since the ASCE student chapter at UNLV's Howard Hughes College of Engineering has formed a team for the AISC Steel Bridge competition. It's been nearly a decade since a team from UNLV actually built a bridge and competed in regionals. A group of 11 unseasoned undergraduates has 6 months to design, fabricate, assemble, and transport their bridge 500 miles away to Logan, Utah. The first order on the agenda? Evaluating leftover materials from previous teams that need to be cleaned and sorted before creating a list of required purchases. Now that the cleaning is done, it's time to design a steel bridge, a task that none of the team members have ever attempted before.
And here's our first iterative analysis of our bridge. In this design, we decided to develop the K-truss with a depth of 6 inches, meeting the dimensional requirements provided by the client. To improve client comfort, our team implemented a 50% factor of safety above the specified aggregate deflection in order to prevent unforeseen fabrication errors or material properties from negatively impacting our client experience. To be under this deflection requirement, this bridge design needed to be made out of solid steel bar stock, which would result in a gross weight of 403 pounds. And while we are UNLV strong, we are not that strong. In the second and final analysis, our design team decided to cut the original design across its neutral axis. This established a new depth of 12 inches, taking advantage of a greater moment of inertia. This resulted in the same aggregate deflection calculated in Design 1, but at less than half the gross weight. In order to reduce the vertical profile of our bridge while achieving the required 20-foot span so that all footings would be on the abutment, a K-truss was selected. This truss allows for minimal material usage by shortening the vertical compression members to prevent any buckling with expected loading conditions. Additionally, this design was selected because it provided efficiency with deflection and materials, although extra time needed to be factored in for prefabrication. The design team used both SolidWorks and Autodesk Inventor for our design, using the worst-case deflection as a conservative estimate of a total aggregate deflection of 0.89 inches for load case 1.
With the bridge designed and Curtis Steel Company providing 20-foot lengths of hot-rolled tubing steel, it's time to cut the steel and learn how to weld the members. But before welding training can start, team members need to undergo safety training at the UNLV machine shop and become acquainted with the tools they'll be using. Students working in the machine shop learn the safe operation of equipment such as saws, angle grinders, sanding belts, and welding rigs. Personal protective equipment worn included safety eyewear, with people wearing glasses having the type that goes on over their glasses. Additionally, anyone in the welding area wore a welding hood, even if they were not actively welding. Those were visually inspected before each use. Anyone working with heavy materials or equipment wore steel-toe boots, and anyone in an area with overhead fall risks wore a hard hat like the one I have on here. Of the 3 team members who welded the entire bridge, only Diana had some experience MIG welding in high school. Maple had past experience with stick welding at a vocational, organic, and biodynamic farm program, and Angelina was completely new to welding. At the machine shop, members were taught how to weld in November and December of 2023. The plan was to practice over winter break so that they'd have enough experience to weld the bridge members adequately. Unfortunately, the campus was shut down over winter break, leading to even less time for bridge fabrication. When the semester started, members of the team juggled classes, work, and material preparation. After prepping the members by cutting them with 14-inch portable saws, smoothing them with a 12-inch disc, 6-inch belt combination sander, and creating a welding jig to hold them in place, welding began in earnest. As the semester progressed, the bridge slowly but surely took shape. Spring break was spent on campus working on the bridge. Having fulfilled the client's requirements for the dimensions and capacity of the bridge, the final step was choosing paint colors. A bright shade of safety red and a matte shade of gray were chosen, both to represent UNLV's scarlet and gray colors, and more importantly, to provide a visible structure for disc golfers to use as a marker for the river and hopefully avoid throwing their discs in the water. Now complete, the bridge was disassembled and transported the 500 miles to compete in the Intermountain Southwest Regional Competition at Utah State University. We learned a lot from the other teams and are very excited to use our new skills and experiences to compete again next year.